Hello guys and welcome to this video where we're gonna dive deep into authentication. We're gonna see how we can create sign up, login and refresh token endpoints, and we're gonna see how we can generate access tokens and refresh tokens to use them in our authentication flow, while of course using guards. So I have here a normal NestJs application. Of course we're listening on port 3000 and this is just the basic setup. The first thing we're gonna do is we're gonna create an auth module. So let's go ahead and say nest generate resource auth to create our auth module, REST API. And now I'm gonna go ahead and then create two folders. The first one is gonna be called schemas for our Mongoose schemas, and then let's create another one called DTOs. And since we're using Mongoose, of course we need to install those two packages, nestjs/mongoose and then the normal Mongoose package. So let's go ahead and install them. And now once this is done, let's go and open up our schemas folder and then create user.schema.ts, and here we're gonna have our user schema. So I went ahead and created a basic Mongoose schema, of course, with the schema decorator, and then we have created three different properties: name, email and password. They are all required, and for the email I made sure to set the unique attribute to true to create a unique index on this, since every user should have a unique email. And now let's go to our controller, and now we need to start creating our different endpoints. So here we have three different endpoints to implement. The sign up endpoint, where the user is going to create a new user by sending their name, email and password. Of course we need to check that the email is not already in use. And then for the login we need to enter the existing credentials to get the access token and refresh token, so that this user can actually use the access token in different requests and use the refresh token to call this refresh token endpoint whenever the access token expires. So let's get started with the sign up first. So since it's going to be a post request, let's go ahead and use the post decorator, and then we're gonna set a route of sign up. So to reach this API endpoint we could say auth/signup, because auth is used as the prefix in this controller. And now for the route handler method, let's say async signup, async because of course it's asynchronous. And then here we need to take a body which is going to contain the data for this new user. And then here we could call it, for example, signup data. And then we need to create a DTO for that signup data. First of all, let's go ahead and import body from NestJs common. Let's give it a type of signup DTO that we're gonna create now. So inside of our DTOs folder, let's go ahead and create a new file. Let's call it signup.dto.ts. And then if we take a look at our user schema again, we can see that we have three different fields: name, email and password, and those are the fields that should be entered in the signup by the user. So let's go ahead and say export signup DTO, and let's take those three different fields and add them here. And of course this is a class, so export class signup DTO, and those are the three different fields that we are expecting here. Now that this exists, we can of course import it. But this is not enough to actually validate the data, because now even though we have set this as the type of the payload, if someone tries to send a request that does not contain those fields or that contains different fields, this is not going to throw an error of bad request. So we have to use a package for that called class validator with a built-in pipe in NestJs. So let's go ahead and do that. Let's go back to our terminal and say npm install, and the two different packages are class validator and class transformer as well. So let's go ahead and install those packages. And once this is done, let's go to our main.ts and actually apply a global pipe so that it validates every different DTOs that we have inside of our route handler whenever we assign them to a body or other decorators. So we can say app.use global pipes, and then here we can pass in the validation pipe. Of course we need to say new, and here we can pass in some configurations. Now I like to pass whitelist true, and then forbid non-whitelisted to true as well. And what whitelist does is it will take away the fields that should not be sent in the body, and then if it is not allowed, it's going to throw an error here. So instead of just stripping them away, it will throw an error. And of course for this to work you also have to have whitelist. I've already covered these in my NestJs series in the validation and pipes videos, so feel free to check them out if you want to dive deeper. Now, in order for this validation pipe to work, we should actually add some decorators here on every field or every property from the class validator package. So let's go ahead and do that. So I added some decorators from class validator. As you can see, for the name, we just expect a string. For the email, we expect an email. This is going to check if this value is an actual email. And then for the password, I added some decorators. Of course, it should be a string. And then we want the minimum length to be 6. Of course, you can set anything you'd like. And to make the password a bit stronger, I just added a regex here by using the matches decorator that expects a number. So if this password does not contain any numbers, it's going to throw this message. Password must contain at least one number. Of course, you can add one for the symbols and so on. You can do anything you want. But this is how I want my Signup DTO to look like. Now, let's go ahead and run our server. And then go to Postman and make sure we select the post HTTP method. And then here, of course, we're running on port 3000 and the route is auth/signup. And if we try to hit send, as you can see, we got different error messages. Name must be a string, email must be an email, password must contain at least one number. So this is perfect. Our validation pipe is now working correctly. However, now when we have a proper body, we are respecting those different constraints. If we hit send, as you can see, we got 201 created. Of course, now we're not actually creating anything, but we are sure that our validation is working properly. So the next step is to actually create a service method for the signup and handle the different logic there. So I went ahead and created a method, async signup, inside of our auth service, which of course takes the signup data, which is of type signup DTO. And then here we have 3 different tasks. We need to check if the email is in use or we can actually use it for this new user. And then of course we need to hash the password by using bcrypt, which is a package used for hashing and other stuff. And finally, of course, we need to save the new user in our database. So to be able to actually do that, we need to set up the Mongoose module in our application. So let's go to app module and do that. Inside of our imports in app module, we need to say Mongoose module. And of course, this is from NestJs/Mongoose, the package that we have installed already. .for root. Then here we need to pass the connection string for our database. Now my database is local, so this is the IP and the port that you're going to be using. And then you need to name your database. We're just gonna call it auth example db. Now, in case you wanna read this dynamically from your env file and from a configuration, which is of course how you should be doing it for production, instead of using for root, you can use for root async. Now, to be able to save to our database, of course, we need to actually inject the user model, the one that we created, inside of our auth service so that we can use it and query our database. Now, to be able to do that, we have to go to the module in which we need to use that model. So in our case, the auth module. Let's go to auth module here, and then we need to import. And here what we could say is mongoose module.forFeature this time. And here we can register the models that we need to use inside of this module. So this takes an array, and then here for the name, user.name. Of course, I have a video explaining everything here, so feel free to go and check it out. I'm going to leave the link in the description. And then here we need to provide a schema, which is the user schema, which is the one that we defined here by using user schema.create for class. And here, if you notice, we got an error, reference error, document is not defined. And this is because here we're extending from document, but it's not actually importing the correct document. The document that we're trying to extend from is the document from Mongoose. So with this change, if we save again and run our server, as you can see, everything is fine. And now with this in place, we can actually inject this user model inside of our auth service and then use it. So what we need to do is, let's come here and inject it in our constructor using @inject_model, and then here user.name is the token, and then we could say private user model, for example, and this is going to be of type model from Mongoose, and then we can give it a type of user, for example, which is this user schema here. So now if we take a look here, we could say this.userModel.find.create and so on. Let's go ahead and implement our sign-up flow. Let's start by checking if the email exists. So let's say, for example, email in use equal await this dot user model dot find one, for example, and we could pass in the email from the sign up data dot email. So now we are checking if we have any document that has this email, and if that's the case, so if email in use, if you got a document, what we could do is say throw new. We could say bad request or conflict exception as you wish. I'm gonna say bad request, and then here I'm just gonna say email already in use. Now for hashing a password, let's go ahead and say npm install bcrypt. And now we can create our hashed password. So let's go ahead and say hashed password equal bcrypt, and of course we need to import it here. So I'm gonna say import star as bcrypt from bcrypt. And then here, if you take a look at bcrypt, we could say dot, right, we need to install the types package. So let's go ahead and do that. npm install at types slash bcrypt. And now if you take a look here, we could say dot, and we can see the different methods. So we're gonna say dot hash, and then here we need to pass in the data that we are hashing. So in this case, our password. And I don't wanna always just type sign up data dot password dot email, whatever. So what I'm gonna do is here, I'm gonna say const, and then I'm gonna extract the email, the password, and of course the name from the sign up data. And then here we could just find one on the email itself right away. And here we could hash our password. So the plain text password that was sent in the sign up DTO in Postman. So in this case, long pass 123, for example. And then if we take a look, we should also pass a second argument, which is salt or salt rounds. You can think of this as another layer of security. So here we can specify a number, for example 10, which is going to be the number of rounds in the algorithm to make it more secure. Salt basically is used to have different hashes for same plain text passwords. So if two different users chose a password of 123, using salts would actually generate two different hashes for the same password, which makes it more secure and protected. So we're done with hashing the password, we're done with checking the email, and finally now we need to create the document. So we could say await this dot user model dot create, and then here we could pass in the name that we extracted, and then the email, and then for the password field we're actually going to use the hashed password so that we store it securely in our database. So this is pretty much it. Let's go ahead and test this out. So here I'm going to go ahead and say return this dot auth service dot sign up, and let's pass in the sign up data. Let's run our server, open Postman, and now if we hit on send, we got internal server error. Let's see what happened. Okay, so basically we forgot to actually await the process of hashing the password here. So we need to await this. We need to wait for this to actually complete hashing the password correctly. And now if we go ahead and hit send, we got 201, everything is fine. If you go back to our database, as you can see, we got auth example DB with the user's collection. And if you take a look, we got name, email, John, and then the password. As you can see, this is properly hashed. And now if we try to actually create another user with the same email, if we hit send, we actually got an error, status code 400 bad request, saying email already in use. So our sign-up flow is actually working properly. Now let's go ahead and create a route handler for the login endpoint. So here we're gonna have a post method, login, and then instead of sign-up data, we're actually gonna get the login data or the credentials. So we could call it credentials or anything you want. And here we could say login DTO, for example, which we're gonna create right now. And then here we're gonna call a login method, which will take the different credentials. Of course, we're gonna build everything right now. So for the login DTO, just like we did with the sign up DTO, let's go ahead and say login.dto.ts. And our login DTO is simply gonna have an email, which is of type email, and then the password, which is a string. Let's go back here and then make the import. Okay, and now let's go ahead and create our login logic here. So the steps here is, first of all, we need to find if this email exists to make sure that the user exists. If that's the case, the next step is to actually compare the different passwords. the password that the user entered in the login form, and then the password that exists on the user in our database. Of course, we're going to be using bcrypt to make that comparison. It will compare the two hashes. Finally, if everything is fine, we are going to generate our JWT tokens. So we're going to generate an access token and then a refresh token, and we're going to talk a bit more about them. So let's get started. So just like before, I went ahead and extracted the email and the password from the credentials, and I'm trying to find a user with this email. So user model.find one, and then we pass in the email. Now, in case we don't have a user, so if no user, we can go ahead and throw an error. And here it's a good practice to throw unauthorized. So we are not going to let the user know that this email does not exist in our system. Instead, we're going to give them a generic message, such as wrong credentials, for example. And of course, here we should not forget the new. And unauthorized exception is going to return a 401 status code. Now, in case we actually found a user with this email, so for example, if we sent john@gmail.com and we actually got this record, we now need to actually compare the password that was sent in the API request, in the request itself, and then the password, the hashed password, inside of our database. And to do that, let's for example say password match, and then we can use bcrypt. I'm gonna say await bcrypt dot, and then here we have a method called compare, which takes two different arguments. The first argument is the plain password that we sent in the request, and the second one is actually the hashed password from our database. So that would be user.password. And now if not password match, so if this returned false, then we can throw an error here, throw new unauthorized, and as well a generic message, wrong credentials. Now, of course, it's a better practice to actually have an errors file, for example, which is going to have your errors that you can reuse, but I'm not going to do that in this video. Before moving forward to the final step, let's just make sure that what we have right now works. So I'm going to return message success. Let's go ahead and run our server, go back to Postman, and this time create another request. Of course, it should be post as well. And this time it should actually be to the login route. And here for the body, let's go ahead and paste this body here. And of course, we should actually remove the name. So let's say we actually send the correct email and password that exists in our database. If we hit send, as you can see, we got message success. However, if our password was incorrect, for example, longpass1234, as you can see, we got wrong credentials. But let's say we actually had a wrong email, so we send jeff@gmail, which is someone that does not exist here. If we hit send, we also got wrong credentials. So that's a good practice. This is a generic message to make sure that users cannot actually find out what different emails exist in our system. Now that we know that everything is working fine here, we still have to generate the tokens and use them. So let's see how we can do that. So first of all, we need to install a package called NestJs/JWT that is going to actually help us generate tokens and verify them. The next step is to actually register the JWT module inside of our app module. So to do that, we could import JWT module from NestJs/JWT and then register it. And here we can pass in many different configurations, as you can see here, such as if this module should be globally used, and the secret. The secret should be securely stored somewhere, so it could be in your environment variable, so in your .env file, and then you can use register async and read it from there. I have a full video on that. I'm gonna do it quickly here, but you should always make sure to never actually push your secrets to your repository. So I made the fixes to actually read those values dynamically, and I'm gonna quickly go over them, but if you want the detailed video, I'm gonna keep the link down below. I have a full video on configuration. Basically, you need to install nestjs/config, which will allow you to actually import a config module, and then you can use for root to register it. I set it as global, and then you need to load a config file. My config file, I created one here. It returns a function with some key value pairs. I have a JWT with a secret, and then, just like we said, the secret should not be statically in the code. It should be securely stored inside of a secure vault. In our case here, we're using a .env file. Of course, it should not be pushed to GitHub or GitLab, so we need to add it inside of our gitignore. So here we could say, for example, .env, and if you take a look now, as you can see, it's no longer highlighted in green. It will never be pushed to your repo, and this is the right way to do it. And I also have a Mongo URL here, so now we can read those in the config file using process.env, and then inside of our app module, we can now use register async and for root async instead of register and for root. And here, I'm gonna go over it really quickly. We're just injecting this config module here, and then we're using a factory function to actually set those URI and secret values dynamically using our config service that we inject here. With that in place, we can now dynamically change those values and have them securely stored. And since we have globally registered this JWT module, now we can actually inject it inside of our auth service here and then use it to actually create a token here. So I went ahead and injected this JWT service from NestJs JWT, and of course this works because we have installed the package and imported this module here. And now if we take a quick look here, for example this.jwt, we can see that we have decode, sign, verify, and so on. Here we need to sign a token. I'm gonna do this in a separate function to keep this one clean. So I went ahead and created a separate method called generate user token, which takes a user ID and is going to actually return an access token and a refresh token. And I'm going to explain the difference in a second. But to be able to generate an access token, just like we said, we can make use of this JWT service to actually sign a token. And it can take a payload. It could be anything we want. I'm going to pass in an object that has the user ID so that whenever we get that access token, we can actually know this token belongs to which user. And then here, if you take a look, we can pass in some options such as a secret key. However, since we're already setting a secret key in our app module here, we already specified a secret key, we don't really need to specify it again manually here. So we can just say .sign, and it's going to use this secret key here to sign our tokens. Now, we could also pass some other configuration other than the secret. For example, we could pass in an expires in, and here we can specify how long it takes for this token to actually expire, because you should not, of course, create a token that lives forever. Usually for access tokens, we give them a short time span, and we use a refresh token to actually keep generating other access tokens. So one main difference between the access token and the refresh token is that an access token has a short time to live, but the refresh token has a longer time to live, and the refresh token is used to actually create new access tokens whenever an access token expires. So that's the main difference and the main role of those different tokens. So here for the expires in, I'm going to go ahead, for example, and say 1 hour. If you take a look here, we could say 2 days, 10 hours, 7 days, and we can also pass in a number. I believe it takes it in seconds or milliseconds. So that's it for our access token. Here we can go ahead and actually return it. And just like we set this expires in here manually directly, we could also have done this here as well. So we could have said sign options, and then here we could say expires in. But just to show you that you could actually put it either way, I'm gonna keep the secret globally here, and then I'm gonna set the expire option here manually. Now, before generating the refresh token, I wanna actually try and return this access token to the user and see how it's formed. So here, let's go ahead and return this.generate user tokens, and then for the user ID, it's going to be the user that we found here. Dot, of course, going to have the underscore ID field here. And then let's restart our server and go ahead and use John, and then the password was longpass123. If we hit send, as you can see, now we actually received an access token. And if we take this token, if you go to jwt.io and then paste our token here, we can see that whenever this token is decoded, we have 3 different parts. We have the header here, which specifies the algorithm and the type. And then we have the payload here. If you take a look, we can see that we have a user ID, the one that we set in our code. And if you take a look at our database, John has an ID ending with 891, which is the same ID that we have here. So we know that this specific token belongs to John. Now, of course, we can decode tokens without actually having the secret key. So I don't really have a secret key here to verify it. But in our code, we're never gonna decode a token and then move on. We're gonna actually verify that this token belongs to our application by checking the secret key. If you don't understand what I'm saying right now, don't worry, we're gonna cover this when we reach the guard part of our application. I also want to point out that here we have the expiry of this token. So if we take this epoch converter, if we take this and then put it here, as you can see, it has 1 hour. So this expires in 1 hour. So in my time zone 2:22, now it's 1:24. Of course, we generated this token 2 minutes ago, so it is actually 1 hour. And this is what we actually set here, 1 hour. So this is actually working correctly. So just like we said, the main purpose of a refresh token is to actually create new access tokens once the expiry time of an access token expires. So it would make sense to actually return a refresh token here. Well, for refresh tokens, we need to save them in our own database. So we need to actually go ahead and create a new schema here. I'm gonna call it refresh token.schema.ts. So our refresh token is going to look like this. We have 3 different properties: the actual token value, and then the user ID, so that we can tell this refresh token belongs to which user in our database, and then the expiry date, because of course a refresh token, just like an access token, is also going to have an expiry date. Now the difference between this expiry date and the access token expiry date is that usually a refresh token is long-lived. So this expiry date would be way longer than the one for an access token. And that makes sense since we are using a refresh token to actually generate many access tokens. Now let's go ahead and register this model inside of our auth module, just like we did with the user. So refresh token.name and refresh token schema. And now we also need to inject this model right here, just like we did with the user. So refresh token again, and then let's call this refresh token model, which is a model, and it's going to have the refresh token type, which is the one that we created here. Now to create an access token, we used JWT service.sign. For the refresh token, I'm actually gonna generate a random long string that we are going to store in our database. Now since refresh token is a random string, I'm gonna go ahead and use a UUID, a very popular package to create unique IDs or unique strings. So I'm gonna be using this package, okay, to generate my refresh token. So let's go ahead and install this package, and then let's copy this. And here, after importing, of course, we can call this function. I'm gonna say refresh token equal this UID, and then I'm gonna return the refresh token. We still need to store that refresh token in our database, but first I just wanna see how it looks like in the response. So let's go ahead and run the server again. And now if we log in again, as you can see, we now also have a refresh token. Of course, you can use any package that you want. You can make it as long as you want, but I'm gonna be using this package. Now we still need to actually save this refresh token in our database. We already have a schema, and we have already injected our model here, so we can use it to create it. I'm gonna go ahead and create another method here. I'm gonna call it store refresh token, which is going to take a token, which is a string. And then here we need to actually create it. So I'm gonna say await this dot refresh model dot create, and then here we need to pass in the token, and of course we also need to pass in the user ID here, because if you take a look, we are also storing the user ID so that we can tell this token belongs to which user. So here we can pass in the user ID. We're gonna have the token, the user ID, and of course we need an expiry date here. So for the expiry date, what I've done is I took the current date and then I added 3 days on that current date, and this is going to be our expiry date. So our refresh token is gonna expire in 3 days. Now we just still need to store the token here, so I'm just gonna say await this dot store refresh token, and then I'm gonna pass in the refresh token as my token argument, and then the user ID. Let's go ahead and save this. And now if you call this API again, as you can see, we got a new access token and a new refresh token. If you go back to our database and if we refresh here, as you can see, we got a refresh token collection, and then we can see that we have one document. This is the token, which is the same refresh token that we returned to the user. And we can also see that we have the user ID, which belongs to John. And if you take a look at the expiry date, we can see that it expires this month, so May 28th. Today is 25th, so this is correctly 3 days. So now we have successfully created our login API, which checks if we have a user by email, and then if we find that user, we are going to match the passwords, the one that was sent in the request and the one that is hashed in our database. And then if everything is correct, we are going to generate an access token and a refresh token, and we store the refresh token in our database, and of course we return them both to the user. And we also said that the access token is short-lived and the refresh token is long-lived, so anytime the access token expires, the front end or the client is going to actually make a request to this refresh token endpoint that we're going to create. So John is going to send the refresh token again to that refresh token endpoint that we're going to create, which will check if the expiry date and the actual token value is correct in our database. And if that's the case, then it's going to create two different tokens for John, an access token, which is a JWT token, which has the user ID and its payload, and then a new refresh token with 3 days as expiry again. So for the refresh token, I created a new handler. The route is refresh. I call it refresh tokens. And then we're gonna get a refresh token DTO, which we're gonna create now. And of course, we're gonna call the refresh tokens service. And then we need to pass in the refresh token. So let's go ahead and go to our DTOs, create a new DTO. I'm gonna call it refresh tokens.dto.ts. And our refresh token DTO, the payload, is just gonna have a token which is a string. And now after the login method, I'm gonna go ahead and create async refresh tokens, and it's going to take a refresh token which is a string. And then here we have a few things that we need to do. First of all, we need to verify that this refresh token exists in our database and has not yet expired. And then we're gonna get the user ID from that refresh token and call this generate user tokens function, so that we can generate a new access token and a new refresh token, which we store again. And yeah, that's pretty much it. It's pretty straightforward actually. So it's pretty straightforward. Token equal this.refresh token model.find one, and we try to find the actual document by searching for the token. And of course, we also need to make sure that it has not yet expired. So expiry date should be greater than now's date. So if that's not the case, if we haven't found this, so it either does not exist or it has expired, we could throw a new unauthorized exception, for example. And at this point, what the front end does, they would throw the client back to the login screen where they have to log in again and get brand new tokens. And if the token is valid, so it has not yet been expired and the refresh token is correct, then what we need to do is actually return a new token. So return this dot generate user tokens, and we need to pass in a user ID. Thankfully, we're actually storing the user ID on this token, so we can simply say token dot user ID. Let's go ahead and save this. And of course, here we need to send the refresh token. Does not exist on type refresh token DTO. Let's call it refresh token and save. And let's go back to Postman and try to actually refresh our existing tokens. Currently, our tokens are these. This is the access token and this is our refresh token. If you take a look, this is the same value. So I'm gonna go ahead, open a new request. It should be a post request, and then here it should be refresh. And in the body, of course, we need to go ahead and send a token. We called it refresh token, so we need to make sure we pass in the correct name of the key. And then let's go ahead and pass in a wrong token first. So I'm just gonna pass this part to see what happens. If we hit send, as you can see, we got unauthorized. Of course, here we can enhance the message. We could say refresh token is invalid or anything else. We could also, just like we previously said, have an error folder that has a lot of error objects that you can define, but this is not in the scope of this video. But anyway, this is a good message. Let's go ahead and actually pass a valid refresh token and hit send. As you can see, we actually got a response. We got a new access token and a new refresh token. So D55, and so on. If you go back to our database and refresh, as you can see, we actually got a new document here which belongs to the same user ID. Now, what we could do is, let's say that we can only have one refresh token per client. Then what we would need to do is remove the previous one. So remove the previous refresh token and only keep the new one. So let's go ahead and do that now. Back in our code, we can simply say find one and delete. So this is going to delete the record. Gonna go ahead and refresh. Gonna delete the first one manually. But now let's go ahead and take this new refresh token, and then back in Postman, let's say we actually want to refresh our tokens. So I'm going to put the new refresh token, hit send. As you can see, we got a new refresh token and a new access token. The refresh token starts with 7F5. If you go back to our database and if we refresh, as you can see, we only have one document for this user with the refresh token of 7F5. So our refresh token is working properly. Now let's say our expiry date actually expired. So this token's expiry date ends in 2023 and now we're in 2024. If I go ahead and try to refresh this token, so let's take this value here and let's try to refresh this token to generate new tokens. If I hit send, as you can see, refresh token is invalid, and that's because it has expired. But if you go back to 2024, for example, update and then send again, as you can see, our refresh token endpoint is actually working properly. Now this is the most basic way of doing refresh tokens. Now if you'd like to actually maybe add some layer of security, make it maybe harder for anyone to try and exploit this route, you could maybe also ask the user to enter their user ID here, and then you would search for the combination in your database. And of course the user would actually have that user ID from the login here. So alongside with the access token and refresh token, we can also pass in the user ID from our login here. So here we can actually store these in a token, for example, in a variable. We could say tokens equal await this, and then here we could say return tokens and then maybe user ID, which is going to be the user dot underscore ID. And now whenever we log in, send, no, that's a sign up actually. Here is the login API. If we hit send, as you can see, we are now also returning the user ID for the actual user, which they can store on their local storage. But enough for that. Now let's see how we can actually protect our APIs and only allow users with an access token to actually call our endpoints. But before we actually implement our auth guard, I just want to say, if you guys are still watching and enjoying my content, please leave a like, subscribe, and I'm probably going to make a part 2 in which we actually implement 2 different endpoints, change password and forget password, in which we actually send an email with a link to reset your password. And I'm also planning on making another video which is going to take care of authorization, roles and permissions, and so on. Now inside of appcontroller.ts, I went ahead and created a route handler, some protected route, which returns message accessed resource. By default, this is a public route, so if I go to Postman and hit send, as you can see, we got accessed resource. But what if we actually want to only allow authenticated users to actually call this route? So users who have logged in previously and got a valid access token. We're going to be using guards for this, so let's see how we can do that. Let's go ahead and inside of the source folder, I'm going to create a new folder called guards, and then I'm going to create a new file. And then I'm going to create a new file. I'm going to call it auth.guard.ts. And this is how a guard looks like by default. It's basically a class decorated by injectable, so we can actually inject it as a dependency in our other services. And it implements an interface called canActivate. So now we need to implement this canActivate method, which takes a context of type execution context, and then we need to make sure that we return a boolean or a promise of a boolean, so with async await, or an observable, just like we do with RxJS. So now it's important to actually return true or false here. If we return false, every request that actually enters this auth guard won't be able to go to the route handler. It will actually throw an error. By default, it throws forbidden 403. But if we return true, then this will allow the request to actually proceed and go to the route handler. So here we need to have some logic to actually check if our request has an access token in the headers, and if that access token is actually valid, so we need to verify it. And if that's the case, we can continue. If not, we can throw an error. So let's see how we can do that. So the first step is to actually inject the JWT service inside of our auth card. And of course, this works because previously in our video, we actually registered the JWT module in app module and we defined it as global. So now we can actually use it here as well, not just in our auth service. And the next step is to actually check if our request headers actually have a token. So technically inside of our request postman, for example, here in the headers, we can add authorization. Okay, we can either add it here or we can also add it here. We can go to authorization tab and then go with bearer token. And then here we can add our token. So for example, in our case, our token or our access token is this. So if you take it and go back here, if we put it here, as you can see, by default, it added this authorization here and it added the word bearer and then space, and then we have our actual token, which ends with VRL, which is the token that we actually added here, VRL, which is the token that we got from our refresh token API. Now to get access to our request headers, what we could do is, let's go ahead and say request, for example, and then using this context, we can actually switch to HTTP. And then here, if we say dot, we can see that we have the next object, the request, and then the response object. Of course, we need the request here. We don't really see what we have, so what we could do is specify that this is a request, and then here we could say import request from express, and then here request dot. We can see that now we have access to, for example, the body, the headers, and so on. I'm gonna go ahead and create a method called extract token from header, which takes a request and then checks for the headers. Okay, so it will take a look at our headers and it will try to find a key of authorization. So here we're gonna try and find this authorization, and if that's the case, we're gonna split the value and then take the first index. So not index 0 but index 1. And if you recall, I previously said that we have here a value of bearer, space, and then the token. So since we need the second value, so index 1, we would need to do that here to only get the token value. So here what we could say is const token equal this dot extract token from header, and we can pass in the request. Now of course this is whining because we're not returning true or false yet, but we're gonna do that in a minute. Now with this token, first of all we need to make sure that it exists, and then we need to make sure that if it does exist, it is actually a valid token. So we could say if not token. Now I like to, instead of returning false, which will, like I said previously, throw a forbidden 403 error, I like to actually throw an unauthorized error with 401. So what I'm gonna do is throw new unauthorized exception, and then for example we could say invalid token, and in case the token is actually here, we have a token, we need to verify it. So I'm gonna say payload equal this.jwt service dot verify, and then here we need to pass in the token, so token. Of course, usually we would need to also pass in a secret, but we don't really need to pass in a secret here because in app_model.ts we already defined our secret and we're already reading it from our env. So let's go back to our guard, and here we could add a try catch block actually, because this will throw an error in case the token has expired or in case we used a wrong secret or whatever. So I'm gonna add this here, and then for the catch block here we could, for example, throw an error, throw new unauthorized exception. We could say invalid token, and here we could use a logger, for example, so logger from NestJs, and we could say error, and then here we could say a e.message to just check what is the problem here. And if everything is fine, we can actually return true. And in that case, if we got the payload, we did not catch any errors, so we have successfully verified our token, we can proceed with true and go back to our route handler. Now usually in NestJs and Express, we attach the user object to the request. So we could say request.user or user ID, and then we could give it the payload or payload.user ID, whatever. Now, of course, it's going to throw an error because user ID does not exist on request. And request here we specify the type as an express request. Now, usually you would go ahead and create your own request. Okay, so maybe you could create a class request with user info, which would extend the actual request from express. But to be faster in this video, I'm just gonna keep it like that with a type of any. And now, whenever we return true, we're gonna have this user ID on the request object. And to verify this, let's go to our app controller, and here we could say @rec, and then I'm gonna get a reference to the request, and I'm just gonna log, or actually I'm gonna return here the user ID, which is going to be from rec.userid. Let's save this. And now we still have to do one more thing, which is actually applying this guard on top of this controller right here. So what I'm gonna do is I'm gonna say use guards on the controller level. Of course, you can do it on the route level or globally, but here I'm just gonna do it on top of this controller, so it will apply to every route that we have. Use guards. I'm gonna say authentication. What did we call it? Auth guard. So I'm gonna say auth guard here, and let's save. And now if you go ahead and try to actually make a request here, but first I'm going to remove the auth, so we don't really have an auth here, and I'm going to remove this. If you go ahead and hit send, as you can see we got invalid token, unauthorized. If you go ahead and add a bearer token, if you hit send, as you can see we actually got a response now, message accessed resource, and then we got the user ID. And this user ID is the one that we actually fetched from the token. So back in our code, if you take a look at the guard, here, whenever we verify this token, it actually returned a payload which has whatever data that we actually assigned on it whenever we actually generated this token. So in our app service, so in our auth service actually, in generate user tokens here, whenever we create this access token, we actually sent a payload of user ID. And this is exactly why we can now in our auth guard get this user ID from the payload. And to verify this, we can go to jwt.io, take a look here, paste this token, and go to the payload data here. We can see that we got this user ID that we assigned whenever we logged in. This way, whenever a user makes a request to a protected endpoint, we are able to tell which user actually made that request by just taking the request and then getting the user ID from it. Of course, you can create a custom decorator here, so you don't have to always inject the request itself. You can create something like user info and all of that, but that's not the point of this video. Now, just to show you a few different errors, let's say we don't actually send a correct token. If I hit send, we got invalid token. If you go back here, we got error, invalid signature, and this is the log that we actually added here. So as you can see, we got invalid signature. Now, let's try to actually generate a token and wait until it expires, and then try to make a call and see the expiration error. So to do that, I'm going to go to my auth service, and then instead of expires in 1 hour, I'm gonna set it to a few seconds. So if I go ahead and save this, now by default, if you don't pass a string here, you just pass a number, it's gonna take it in seconds. So now if you generate a new access token, it's gonna be 10 seconds. Let's go ahead and log in as this user, as John. We got this token, the 10 seconds has started. If I go to bearer token and paste this token and hit send, as you can see, we got access, everything is perfect. But let's wait a few more seconds and then hit send again. As you can see now, we got invalid token, unauthorized. If you go back to our code, you can see error JWT expired, which is from our guard here. Now, here, what happens is that the front end is actually going to take the refresh token. So after logging in, this is the access token that expired. We have the refresh token that we got from the login API, and the front end is going to make a request to the auth refresh API, paste the refresh token here, and of course everything is working fine. If we refresh our database, oh, we saved more tokens. So basically, whenever we are logging in again, we are creating a new record for the refresh token. We're not deleting the previous one. I'm gonna show you how we can fix it in a bit. But for now, we got this refresh token, DCB, which is this one. And we got an access token that expired after 10 seconds. So what we could do is call the refresh token API, pass in this token, hit send. We generated a new access token and a new refresh token. Of course, the access token is gonna have an expiry of 10 seconds. So let's send. And as you can see, it's now working. But if you keep calling it after 10 seconds, eventually it's gonna be invalid because it has expired again. Now let's say for your application, you just wanna have one refresh token document for your user. Maybe that's your use case, that's how you build your application. So we don't really wanna create different refresh tokens for the user every time they log in. We just wanna replace the older one. Okay, let's say that's our use case or business logic. What we could do is, first of all, whenever inside of our refresh token we used to do find one and delete to make sure that we're deleting the previous one, let's just keep it find one here, it's fine. And then here, whenever we are storing a refresh token, instead of actually creating it, we're gonna use update one. And then here in update one, we're gonna search for a token. Okay, we're gonna search for this token with this user ID combination. And then we're gonna set the expiry date. And then here is the key point. The most important part is using upsert true. Let's check that this is working correctly. I'm gonna go ahead and delete all of our records here. And now I'm gonna go ahead and log in once as John. If you go back, we refresh, we can, okay, why did we get two? Okay, my bad. Here we should actually only only search on the user ID, since we're gonna have one document or one refresh token per user. So we need to make sure that we only have one. So we search on the user ID, not the user ID and the token. And then here we set the new token value and then the expiry date, and upsert true to make sure that we at least have one document. So if it does not exist, we end up creating it. If it exists, we just update those two fields. Let's try to do that now. If we hit on login, if we open this, we can see that we have one document. If we hit send again, go back here, refresh, as you can see we still have the same record, but this time we have updated the token, so it ends up with CA2. If we send again, it should end up with EDD. If we open this, refresh, as you can see it ends up with EDD. So this is based on your actual use case. If you don't mind having different refresh tokens for any reason, that's fine. You can just create and not use update one with upsert. And also let's see if we can actually, if when we call refresh token, if it's going to create a new document or actually update it. Technically it should update it because we're still calling this store refresh token function. If you go ahead and refresh, as you can see we actually got the newly generated refresh token 7F8, which is 7F8. So to summarize everything, we created an auth module. This module has two different schemas. Now, of course, the user schema, in case you had some users related APIs, you could have went with two different separate modules. You could have created a user module, but since here we don't really have a user module, I just added the user schema inside of the auth module. And we also have a refresh token schema, which was going to have the token, the user ID, and the expiry date. We have some basic auth APIs such as sign up, log in, and refresh to refresh our tokens and generate new ones. For the sign up, it's pretty simple. We just check if we have an existing user with this email in use. If that's the case, we don't allow the user to create a new account. If not, we can actually hash the password by using a package called bcrypt. And then we create this new user in our database with the hashed password, name, and email. And then for the login API, we need to pass some credentials, the email and the password. And then here, first step is actually finding a user with this email that the user entered. If you don't find that user, we throw an error, wrong credentials. However, if we do find a user, we need to compare the passwords, of course, using bcrypt again. We need to pass the plain text password from the request and compare it with the found user in our database, so the hashed password. If it returns true, then that's amazing. If not, we can throw an error, wrong credentials. And then finally, we need to generate some tokens, such as the access token and the refresh token. The access token is a JWT token. It is created of three different parts: headers, payload, and signing secret. Now, to be able to use this JWT service, we had to inject it here, and of course, for that to work, we needed to actually import JWT module after actually installing NestJs/JWT. And here we can set some default configurations, such as the secret that we said should always be in a secret vault or somewhere protected and should not be exposed. We need to set it to global, and now we are able to actually inject it in our auth service and use it to sign and to verify tokens. In this case, we signed this token, we created a token, we signed it, we specified a payload, which is our user ID, and then we gave it 10 seconds as an expiry date. Of course, in real life, it's not going to be 10 seconds, it's going to be more, depending on your application. It could be 24 hours, it could be a week, it could be 6 hours, depending on your application. We also said that we need to create a refresh token, which is going to be long-lived, so it's going to have a longer period of, or a longer expiry date than the access token. It should be a random string, so I went ahead and used UID. You can use nano ID, you can use any string generator that you want. And then finally, we need to store this refresh token in our database as such, so that whenever we need to refresh and create new access and new refresh tokens, we can actually check if this refresh token is valid, hasn't expired, and belongs to the user before actually refreshing it. And then finally, we are returning those tokens and the user ID to the client so that they can use them, so that they can make calls or requests to the server with that access token to protected routes, and we're going to see them in a minute. But first, we also said that we need to have a refresh tokens API. So just like you see here, it's going to take a refresh token. And then here we need to find or make sure that this token exists and hasn't expired. And if that's the case, we generate new user tokens based on the user ID of that token. So that's pretty much it for this. Now, to be able to protect routes from unwanted access, so for example here, our app controller has one API that should be protected. So we can make use of guards, which is something available in NestJS. So basically it's a class decorated with @injectable that implements the canActivate interface. So we need to actually implement that method, which should return true or false. Of course, it could be a promise or an observable as well. And here what we did is we took the context, got the request out of it, extracted the token from the header, from the authorization, and then we used the JWT service once again, to verify our token and make sure that it's valid. Of course, as well, we need to pass a secret. We don't have to do it here manually because we already did it again here in our configuration. And then we said that we can attach the user information, the user object, the user ID, whatever you need on the request object itself. And then, of course, we're catching any errors provided by the verify. So if the JWT expired or it's not valid or whatever, and we can return an error, else we give access to the request or to the user to access our server, and here they were able to reach this route handler. That's pretty much it, guys. Please make sure to leave a like and subscribe if you enjoyed this video. I'm probably gonna make the next video maybe in 1 or 2 weeks. Let me know if you wanna see something else, and if you have any suggestions, please let me know down below. I'm gonna keep some resources for my NestJS playlist down there if you wanna take a look. Thank you for watching, and see you next time.